Hello friends, this is Ravi. Welcome to Tech Lake Video Tutorials. In this ongoing Delta Lake video tutorials, today video I'm going to give you more information about what is Optimize, how it works, when we will use this Optimize. Okay, so for that we should have some basic idea about disk IO, disk input output operations per second. What is small files issue and big data? This is one of the common issue where it comes to if you have more number of small files, performance issue. Performance issue. What I'll do, first I'll create one delta table with a more number of files. Then I'll explain what is optimized. In Databricks, if you go to Community Edition or if you go to Enterprise Edition, you can access Databricks data sets. So here you can find a lot of data files for POC purpose, for learning purpose, which you can use these data sets. So here what I'll do, I'll have some A-line data in this location. I'll use that A-line data to explain you what is optimized, how it works. What is optimized, how it works. There's a folder called ASA, and inside this there is another folder name called A-lines. So here you can find a lot of CSV files. So around 22 CSV files are available. Even some CSV files are bigger size, some CSV files are smaller size. Okay. So here you see this is the bigger in a size in a bytes. Bytes you can convert into kilobytes to megabytes, which it will give you 670 MB. This is the file. Some files are 600, 500 like this. The smaller files, here it is this one. Which is 121 MB. And bigger file it is like this, 22 files are available. I'll read these files. I'll create a delta table. While creating, I'll go with the multiple files. I'll tell you that. I'll create a data frame. I'll use a Spark Read API, CSV, and I'll read with the header equal to true. Then I'll write into delta. Format delta and save as table. It's A lines. So what I'll do, while writing, I'll do the repartitioning. So repartitioning 100. So I'll write into 100 files. I'll write into 100 files. Then write format, you can use a mode, overwrite or append. Now, I'm going to read a 22 files. Then I'm going to write into target, destination as a delta table, 100 files. 100 files. So now we'll understand the common issue in a big data lake, majorly data lake, small files issue. So what is exactly this small files issue? Okay, small files issue. Consider if you have 1 GB data in one file, if you have a 1 GB data in 1000 files. So if you are reading data, same 1 GB data, if it is available in one file, same 1 GB data, if it is available in 1000 files, maybe that file size 1 MB, consider 1024 files. So which one will give a better performance? So in this scenario, if you have a more number of small files, so every disk will have a input output operations per second. That is called disk IO. Disk IO. Disk IO per second. If it is a hard disk, so most of the disk will have a less than 200 IO. IO means per second you can read 200 files. If it is traditional hard disk. If it is a modern, this is a SSD, solid state drive. So it will be having around 500 to 40,000, which you can read 500 files to 40,000 files per second, depends on generation. Even SSD, many companies are providing. Some companies will give you 3,000, 4,000, 10,000, like this. 40,000, that's a limitation. Most of the disk, SSD is faster than traditional hard disk. Why? Mean if you have a more number of files. If you are reading 1 GB data, it will take more time. It will take more time rather than reading data. It will take more time for opening and closing files. Opening and closing files rather than reading data. That's one of the major issue in a data lake. If you have a more small files, then it will take more time. Rather than reading data, it will take more time to open a file, then close the file. So if you have 1024 files, 1024 files, it's need to open, then read the data, then it need to close the file. So that we will call it as a disk IO. Per second, how many files you can read. Traditional hard disk less than 200, like 50, 80, 100, 120, like this, less than 200 files which you can read in traditional hard disk. If it is a modern SSD, minimum 500 to 40,000 files which you can read per second. That is disk IO per second. So this is one of the major thing which big data, when it comes to, if you have a more number of small files, mainly in streaming they will send you less than 1 MB data, maybe KBs. That files sizes may be in KBs, but if you have millions of files, so it will take more time opening and closing. So to avoid that, Delta is giving one option. If you have a more number of small files, if you have a more number of small files, it will remove all small files. It will create average file size 1 GB file size. If you have a 10 GB data, if you have a 10 files or maybe 100 files or 200 files, then it will take all those files. It will create average file size 1 GB. So that is called optimize. I'll show you now. If you go to this location under user, under Hive, default of this table location, in this location you can find data files, which is this directory. Delta is having a directory, and you can see pocket files, 100 pocket files, because we did repartition 100. So this 22 files data, it's written into 100 files. Those 100 files with different sizes, but all files are lesser size, less than 100 MB. So these are our files. You can see 100 files are available. And when you are reading data from this table, right, what will happen? If you do that, read the data files, but I mean, maximum when it comes to displaying in a UI. So here, so 10,000 rows, you see this, right? So 10,000 rows with a header. If you have more than that, you can go and download. There is an option called download more than 10,000 records. It's in a CS file. So whenever you do this, what will happen? That entire data, it get downloaded. Means the job will execute in a backend. It will open and close all that 100 files. If you go to the Spark UI, so count may just, it will take the stats, then it will give you. When it comes to here, 10,000 records it is displaying. If you go on the SQL data frame, which you can verify that UI here, you see this. Only one file it is reading, 99 files it is pruning. So it is skipping 99 files because it is not displaying all the data. When it will display all the data, because the default limit will get applied here. Okay, that's a 10,000 rows. If you go and download all the data, now it will open and close all 100 files because it is trying to read all the data. So in this scenario, if you have a more number of small files, what will happen? Every file it will open and close. Every file it will open and close. That is called disk IO. If you have more number of small files, that every file it should open and read the data, then close. So this table is having 100 files. These 100 files it will open and read the data, then it will close the file. Okay, now, so what is optimize here? How it will work? So now if you run optimize on top of this table, it will take all this 100 files data, then it will create new files with average file size 1 GB. Average file size 1 GB. Now it is going to read all files. You can go to here, can verify this in the description. So it is trying to open all the files, and it will try open all 100 data files. It will read the data because we're trying to download the data. And even when you go to the SQL data frame, this is a current in progress. You can see this. Okay, number of files it is reading, 100 files it is reading. 100 files it is reading. And the data number of rows also, it will show you that number of rows. Okay. Now normally default, if you are displaying 10,000 rows, if you're not displaying here, if you are downloading, then it will read all the data. By default, it will limit will get applied. If you're not displaying, just if you're downloading, you see this all the data. Okay, if any other reporting team, if they are reading data from this table, if they're looking for all the data, then it will read all the data. So now this 100 files, if you run optimize, then that 100 files data, it will create 1 GB file, depends on size of the total size. If you have a 3 GB, it will create a 3 files, 4 GB, 4 files. Okay, just wait a few minutes. So we are going to run this. It's a downloading entire data. Then we'll run optimize on top of this. Optimize on top of this. Then I'll show you that a backend. I'll show you in a backend. So whenever you run optimize, then it will remove all small files, like 100 files are there. It will remove 100 files. Then it will create a new files with average file size 1 GB. Looks like it is taking more time. I'll cancel this. Now I'll run optimize. So how to run optimize? So you can use, because it's a table or even delta table by metastore or by path, you can use optimize table name. So whenever you go with optimize, what will happen in a backend? So compaction will happen. So it will take all files, then the data it will store in memory, then it will create a new files. Then logically that 100 files it will remove logically, because the default time travel will be there. So physically the data files 100 files will be there, but logically those files will get deleted. So it will be a new version. Now you see a lot of jobs are running. You see this? So it is taking all the files data, it will keep it in memory, which you can go and verify the Spark job. Sorry. So you can verify here in a SQL data frame, which is in progress here. A lot of execution job IDs. You can see this, and you can see this optimize is going to run, and you can see the details about a plan. Okay, and temporary folder. This is a temporary folder. Then if even you can go to the jobs, or even you can go to the storage. Okay, so storage by default delta metadata, it will be cached default, cached and default. Even stages information also you can see this. So currently this job is running. Okay, optimizing 100 files. Okay, so it will take that data, then it will create the new files. That new files always depends on size. So the default size is 1 GB. The default size is 1 GB. There's a parameter which by default Databricks delta one parameter is available. So that delta optimize max file size, there's a parameter which I'll show you that after this. By default that parameter value, which you can get that using spark.conf.get. So spark.databricks dot, so delta dot optimize max file size. So this parameter is having a value, default value size in a bytes, and that total size is 1 GB. Total size is 1 GB. So based on this, it is going to create new files with average file size 1 GB. So depends on the project requirement, which we can increase or decrease. okay, which you can increase or decrease. And optimize is an option. If you have a more number of small files, you can run on top of that. Then it will remove smaller files. These 100 files, it will remove logically. Then it will create a new files with the average file size 1 GB. Let's wait after some time. So in progress, it will take some time, and optimize is not a daily development activity. Purely it's a production support activity. We will identify list of tables which is causing a performance issues, which is having a more number of small files. Then you can run on those tables only. Now optimize is completed, and you can see the statistics. Number of files removed 100, number of files recreated 10. Actually 100 files are available, but it's recreated those files. So means removed all 100 files, recreated additional 10 files. Now go and refresh now. This location 100 files except this delta folder, then another 10 files. These 100 files logically it is removed. You can see now another 10 files are available, which you can go and verify the size. Okay, which you can go and verify the size. You see this 10 files. These are 10 files. Okay, the 10 file sizes also you can see this. So average file size depends on this parameter. So by default, this parameter is having this is size in bytes, 1 GB. You can convert into kilobytes to megabytes, 1024 MB, 1024 MB. And again, it will decide based on the size, data size. So 100 files it is removed, 10 files it is newly created, and that also you can see the statistics. Okay, so total file sizes, that statistics also you can see this. And default parallelism it is applied, 16 parallelism. This node is having a 16 virtual CPUs, 16 tasks it can run. Now whenever you read this table out again, so instead of reading 100 files, so select start from. Now if I go and download this data, instead of reading 100 files, it will read only 10 files. Now if I go and download this data, right? So it will execute to read all the files. Now how many files are there? Only 10 files are there. Now if you go and verify this job in a backend, instead of reading 100 files, it will read only 10 files, because optimize is recreated the 10 files, that 100 files data. Now you can go and see here. So number of files it is reading, 10 files. Okay, now it is recreated. It is recreated all data. And again, optimize. Why we need optimize? Optimize is required to avoid a small file sizes issue. If you have a more number of small files, it will take all the data, it will create a new file. Then these 100 files are already deleted. So those it will get purged if you use vacuum. Vacuum again, it will keep 7 days data. So vacuum, if you go with, you can verify the dry run, or you can go with retain 0 hours, which you can go and purge these 100 data files. Now the original data files are post return. This is okay, these data files. Okay, so this is about delta optimize. This is about delta optimize. Now it is reading all the 10 files. Now if you don't want this deleted data files in this location, now you can run vacuum, then it will delete all those 100 files. So optimize is one of the options to improve the performance. When if a table is having a more number of small files, optimize will identify the small files, all the small files, and it will recreate a new files. It will create a new files. And the default block size means that optimized file size, there is a parameter is available, max file size. Max is that. Okay. If you want to increase or if you want to decrease, which we can set here. So that is the default size is 1 GB. So this is about optimize and how it works and when we can use this. If you like this video, please subscribe my channel. See you in another video. Thank you. Have a good day.